So we have inverse functions here, and if the inverse functions were on the inside, we'd have to worry about what was being fed to them. But because the non-inverse, the normal sine function happens first, sine is going to return something between 1 and minus 1. If you recall, sine wave looks like this. And it goes between, all things being equal, it goes between 1 and minus 1. So whatever sine is going to tell us, it's going to tell us something between 1 and minus 1. And so the inverse sine is going to be fine with that. It's not going to be outside of its range. It's going to be delighted with that. And we know that inverse sine is looking for an angle, and we will return the angle. I wish I had drawn this differently now. Let me just try to extend this the best I can. We know that we're looking for between negative pi over 2 and positive pi over 2. It's not the cosine. Cosine's between 0 and pi. Maybe that's what I was thinking. Anyway, we are limiting ourselves right there to those values in between. And so that's what we're going to keep in mind. That's the deal that we've made in order to have an inverse function, because if we don't, as you can see, it would fail the horizontal line test. Like here's a horizontal line, it fails. But because we limit ourselves, it does not fail. Okay, so the sine, the first thing is sine of 5 pi over 2. And we say, hey, too much. You're going around in circles. 4 pi over 2 is the same thing as 2 pi, right? So let me just subtract that from 5 pi, and I'm going to have sine of just pi over 2, okay? And the sine of pi over 2 is, well, it's 1, okay? It's up here at the top. It's right at the very top of the wave. There's the sine of pi over 2. It's 1. And we kind of knew that anyway. When we were drawing our circle, we start down here on the x-axis and up here on the y, and we're full in the cosine x equals 1 direction when we start. But as we swing up to 90 degrees, then it's all about y and it's all about sine, and so we get the full value of 1. And 1 down here when we started, but when we swing up to pi over 2 or 90, we get 1. So we're not surprised by that. And we're saying, if you say the sine, the arc sine or sine inverse sine of 1, what angle could that possibly be? Well, it's pi over 2. And there we go. That's our answer, pi over 2. So it's not going to return 5 pi over 2 because that's outside the limits. 5 pi over 2 is over that way, but we trimmed it down to size, and that allowed us to get something inside the range, the domain, I guess I should say, of arc sine. Okay.